Let us discuss on another numerical on pump. A statement of this problem is as follows. A pump has displaced volume of 100 centimeter cube. It delivers 0.0015 meter cube per second at 1000 rpm and 70 bar pressure. If the prime mover input torque is 120 Newton meter, we have to determine first what is the overall efficiency of pump, and second, what is the theoretical torque required to operate the pump. Let us start a discussion on this numerical for the pump. In this numerical, a given data, displaced volume is given. Displaced volume by the pump is given 100 centimeter cube. Here displaced volume is nothing but volume displaced by the pump per revolution. So if you consider centimeter cube per revolution into a meter cube per revolution, then 100 into 10 raised to minus 6 meter cube per revolution. In one revolution, that means displacement of a volume takes place through the pump. Second, we are having a discharge. So this discharge is the actual discharge by the pump. It is 0.0015 meter cube per second. Then a speed at which the discharge is by the pump is 1000 rpm and the pressure is 70 bar. So let us convert this 70 bar into Pascal. So 70 into 10 raised to 5 Newton per meter square or Pascal. And the torque by the prime mover is actual torque to the pump. It is 120 Newton meter. Now we have to determine first the overall efficiency of the pump and second a theoretical torque required to operate the pump. Okay, let us find the solution for the given problem statement. The first thing, the hydraulic pump is driven by a prime mover. Let us consider it is connected through the shaft prime mover, and pump delivers the actual flow, that is 0.0015 meter cube per second, and Qt is the theoretical flow rate by this pump. So input torque for the pump to drive the pump is given by a prime mover. So let us consider this is actual torque to pump, and that is 120 Newton meter. Now let us find overall efficiency of this pump. Now when we are talking about overall efficiency, we have to consider input power. So input power to the pump is by the prime mover. So it is given by knowing the torque at the shaft into angular velocity of the shaft. We can determine the input power to the pump, and the output power, as we discussed in earlier numerical, is the hydraulic power. So that hydraulic power is the output power by the pump. It is given by P into actual flow rate. Since we are interested in finding out overall efficiency, so we are considering actual discharge by the pump. So this is shaft power or a brake power. Now by understanding this figure, now we will determine the first quantity, that is overall efficiency of the pump, can be obtained by using overall efficiency. Overall efficiency is the ratio of output power to the input power. So output power is hydraulic power and input power is the shaft power or the brake power. Now hydraulic power, it is given P into QA, actual discharge, upon TA into angular velocity. Now here angular velocity can be determined by 2 pi n by 60. So speed of pump at which it is delivering the flow is 1000 rpm. So 2 into 3.14 into 1000 rpm divided by 60. If we calculate this, equal to 104.667 radian per second. So this is angular velocity. Now let us substitute all this quantity in this formula. So pressure is 70 into 10 raised to 5 into actual discharge by the pump 0.015 divided by actual torque is 120 Newton meter, and the angular velocity is 104.667. If we calculate all this value, we will get overall efficiency 0.83598, or in other words, percentage 83.598% is the overall efficiency of the pump. This is answer 1. Next, to determine theoretical torque required to operate pump. There are different ways to determine theoretical torque. One can first determine a theoretical power by knowing the pressure and theoretical discharge, and then we know that theoretical power is equal to theoretical torque into angular velocity. Thus we can find theoretical torque. Otherwise, we can use a direct formula. A theoretical torque is given by a volume displaced into pressure upon 2 pi. So volume displaced is 100 into 10 raised to minus 6 meter cube per revolution into pressure is 70 into 10 raised to 5 Newton per meter square divided by 2 pi. If we calculate, we will get the theoretical torque is 1114649 Newton meter. This is answer 2. So we got answers for this given numerical. The first, overall efficiency is 83.59%, and second, a theoretical torque 11146.4649 Newton meter. Thank you.